Computer Science 461, Quality Concepts. Today we're going to introduce some things called Total Quality Management, ISO 9000, and some other systems and approaches to quality. So let's start with a really interesting source on quality. And this is Robert Pirsig's classic Zen and the Art of Motorcycle Maintenance. Now, if you've read this book, the story has three different plot lines. One is cross-country motorcycle trip. The second is the narrator's reconciliation with his son, and the third, which is probably of most interest to us today, is an inquiry into the nature of values and quality. And the quote, of course, from this book is, "And what is good, Phaedrus, and what is not good? Need we ask anyone to tell us these things?" And this book is actually quite a fairly read as well. Despite the obvious connection to hippies, I would suggest reading it. Pirsig called his approach the metaphysics of quality, and the philosophical inquiry that he takes is quite deep. And so it's good because you can actually appreciate the book on several different levels. But let's take a look at what it has to say about quality. Quality. You know what it is, yet you don't know what it is. Perhaps that's self-contradictory. But some things are better than others. That is, they have more quality. But when you try to say what the quality is, apart from the things that have it, it all goes poof. There's nothing to talk about. But if you can't say what quality is, how do you know what it is? Or how do you know it actually even exists? If no one knows what it is, then for all practical purposes, it doesn't exist at all. But for all practical purposes, it really does exist. What else are the grades based on? Why else would people pay fortunes for some things and throw others in the trash pile? Obviously, some things are better than others. But what's the betterness? So round and round you go, spinning mental wheels, nowhere finding any place to get traction. What the hell is quality? What is it? So, quality is a characteristic of thought and statement that is recognized by a non-thinking process. Because definitions are a product of rigid formal thinking, quality cannot be defined. The study of the art of motorcycle maintenance is really the study of art of rationality itself. Working on a motorcycle, working well, caring, has become part of the process to achieve an inner peace of mind. The motorcycle is primarily a mental phenomenon. So, if you don't have a copy of this book, make sure to see your friendly stoned-out hippie in Pune. They'll probably have a copy of it in their backpack that you can borrow. Or you can listen to the entire audiobook on YouTube if you don't want to bother with the reading aspects of this. So Pirsig says that it's very difficult to define quality if you can do so at all, that it's part of a process. So what is quality? You probably have your own ideas, but let's take a look at how some people have attempted to define it. And we'll begin with ISO 9000. Now this is the International Organization for Standardization. ISO 9000 views quality as a characteristic of an entity. Quality assurance is defined as a set of activities whose primary purpose is to demonstrate that an entity meets all requirements. So, in short, ISO defines quality as conformance to requirements. So, why might this conformance to requirements approach not necessarily be applicable to software, or what might be some of the problems with that? Well, one, you may have requirements that are not included in the specification. Two, there are some points of ambiguity in some of the quality characteristics for software, for example, maintainability and safety. And it's really, really difficult to write complete specifications for software, as you are aware after taking this class. So, there are some other limitations because ISO was originally created for manufacturing. There are some limitations when it comes to applying it to software. One, software is designed. Two, software is a creative endeavor. And three, there is a lot of commercial pressure to have early release of software. So those are some of the limitations that impact quality for software. So what is this ISO 9000? Again, ISO is the International Organization for Standardization. The acronym's a bit out of order there. But ISO 9000 is the most popular quality standard in the world and applies to almost all types of organizations regardless of their function or product. Basically what you do is you develop a quality system to meet the quality requirements of the ISO standards, and typically this involves the development of a quality procedures manual and adherence to this manual. Once you've developed your system, you need to carry out an internal audit to make sure your system is working properly. Next, an external auditor or a registrar will evaluate the effectiveness of your quality system and see if you are actually conforming to it. He or she will then issue an official certificate upon acceptance, and your company will be recorded into the ISO9000 registry. You also get a nifty flag at the end of this certification process, and it sounds fairly straightforward, but it's a lot of work to actually get ISO certified. Basically, it boils down to the following adage: say what you do and do what you say. Anyway, let's take a look at some of these quality management principles that you need to have in your quality plan. There are 8 principles for quality management, and here are their benefits. Number 1, customer focus. Organizations depend on their customers and therefore should understand current and future customer needs, should meet customer requirements, and strive to exceed customer expectations. The benefits of having the customer focus are increased customer satisfaction, greater market share, and revenue. Number 2, leadership. Leaders establish unity of purpose and direction for the organization. They should create and maintain the internal environment in which people can become fully involved in achieving the organization's objectives. Benefits of leadership are employees will be motivated towards the organization goals, and there will be minimal miscommunication. Make sure not to step in the leadership. Number 3, involvement of the people. People at all levels are the essence of an organization, and their full involvement enables their abilities to be used for the organization's benefits. The benefits of this: motivate and involve people, employees feel free to innovate, and people take responsibility for their performance. Number 4, process approach. The desired result is achieved more efficiently when activities and related resources are managed as a process, in short, scientific management. Benefits: lower costs and shorter development cycles, and improved and more consistent results. Systems approach to management. Identifying, understanding, and managing interrelated processes as a system contributes to the organization's effectiveness and efficiency in achieving its objectives. Benefits: this integration and alignment of the process, and focus on key processes. Principle 6, continual improvement. Continual improvement of the organization's overall performance should be a permanent objective of the organization. Benefits: performance advantage, and alignment of improvement to strategic intent. Principle 7, factual approach to decision making. Effective decisions are based on analysis of data and information. Now later on we'll see Peter Keene, who says that actually when we make decisions we ignore information and go with very simple explanations. But let's go with what ISO says, and that basically it's effective decisions are based on analysis of data and information. This allows us to make informed decisions, and we can demonstrate the effectiveness of past and present decisions. Principle 8, mutually beneficial supplier relationships. An organization and suppliers are interdependent, and a mutually beneficial relationship enhances the ability of both to create value. Benefits of mutually beneficial relationships with your suppliers are flexibility and joint responses to changing market and customer needs, and creation of value for both partners. So you may have heard about ISO 9001, ISO 9004, and ISO 14000. These higher numbers don't necessarily mean that it's one step better. Some of them exclude certain requirements, and some of them have different requirements that you're adhering to. ISO 14000 is an ecological standard. So where does this leave software? Well, ISO has a series of standards for software, and these were called ISO 9003. They describe controls and methods for producing software to meet requirements, and it's a framework for describing responsibility, documentation, audits, and corrective action for software development to meet ISO 9000. 20 clauses in the ISO 9003 management of responsibility, quality system, contract review, design control, document control, purchasing, purchaser supply product, product identification and traceability. Process control, inspection and testing, inspection, measurement and test equipment, inspection and test status, control of non-conforming products, corrective action, handling, storage, packaging and delivery, quality records, internal audits, training, servicing, and statistical techniques. So you should have processes in place for each one of these, or quality procedures to ensure quality in each one of these areas. If you'd like more information on ISO 9000, make sure to visit their website, and it's www.iso.org. And the particulars change all the time, but the general idea is still the same. Say what you do and do what you say. Well, that's an overview of ISO 9000. Let's look at another quality system called Total Quality Management. And here we're going to talk about somebody named W. Edwards Deming. And there's Deming there, and yes, that is a Japanese building. Deming was an eminent scholar and teacher in American academia for about half a century, published hundreds of original papers, articles, and books covering a wide variety of interrelated subjects, did a lot of work in statistical variance, systems and system thinking, and human psychology. He did a lot of work in Japan after World War II, and actually eventually did come around to working with the American auto industry after they ignored him. So what is total quality management? Well, technically Deming talked about a philosophy called the Deming system of profound knowledge, and was probably not the originator of a lot of these ideas. However, he did bring the ideas into far wider circulation, and he allowed the Japanese manufacturing industry to flourish after World War II. So TQM stands for Total Quality Management, and it was expounded by Deming in the 1950s. It was ignored by the United States and the Big Three in particular, but it was implemented by the Japanese. And it's a holistic approach. Hard and soft factors are involved, includes people, processes, and results. And there were 14 points. Create a consistency of purpose and continual improvement. Adopt the new philosophy by management and workers alike. Do not depend on quality inspection. Build quality into the products and process. Choose quality suppliers over low-cost suppliers. Improve constantly. Training on the job. Have leadership, not supervision. Eliminate fear. That is, encourage two-way communication. Encourage employees to work to the organization's interests. Break down internal barriers. Eliminate slogans. Eliminate numerical targets. Management by objectives encourages lower quality. Remove barriers to worker satisfaction, including annual appraisals. Encourage self-improvement and education for all, and everyone is responsible for continual improvement in quality and productivity, particularly top management. So total quality management is actually a philosophy integrating humanistic principles as well as scientific methodologies. The integration of quality management, methods, concepts, and beliefs into the culture of the organization to bring about continuous improvement, in Deming's words. So, visible effects of total quality management. One, it removes hierarchical differentiators. All people wear the same uniform within the organization. Commitment to the mission by all staff. Application of resources. You have quality circles and heavy use of teamwork. And continuous striving for improvement. So, some of the characteristics of a total quality management organization: customer-centric, common procedures, long-term commitment, and motivated staff. So, some of the principles that he has for total quality management: clarify your concept, realize your concept, has system and process management. This is the core of total quality management. Constant learning, teams and leaders, and reap the rewards. And if you're interested in that, I actually do have a text in my office called the Deming Management Process. The important thing that you'll need to note is something called Deming's Wheel. And Deming's Wheel basically works to identify the source of variations that cause products to deviate from customer standards. And it has a continual improvement philosophy. Now you see the little stick figure guy pushing the wheel up the hill. Basically what you do with Deming's wheel is you plan, you do, check whether you achieved what it was that you had planned to set out to do, and act to make corrections. You can often visualize this as the line whose slope corresponds to the quality of your product. So as you continually repeat this cycle, the quality of your product will improve as you push that wheel up the hill. The cynic in me says it's a bit of a Sisyphean task. So what are some of the costs of poor quality? Now, a lot of the information that I've been using comes external from Sommerville, but Sommerville does document the costs of poor quality. Well, one is the cost of prevention. This is money spent to ensure the work is done correctly. You allocate money early and the defects decrease. Cost of appraisal. This is time spent on inspection and testing. Increased dollars are spent over time as you increase testing. Internal failures. These are costs of rectifying everything that's wrong before you deliver it to the customer. And last but not least is external failure. This is cost incurred to fix defects after it's delivered to the customer. This is warranty work. So which one of these do you think costs the most, and which one do you think costs the least? So product metrics and measuring quality. Again, this is from Sommerville, and he does have several good metrics for measuring software quality. He divides these into static and dynamic. Static are design, program, or documentation metrics, and dynamic is metrics that are collected when the program is actually in use. And there's an interesting section on analysis of measurements. For example, is it better to have a high number of change requests, or is it worse to have a high number of change requests? Well, high number of change requests means that users are actually using the system, but the system may not meet their current needs. A low number means the system's either stable and functioning well, or that no one is using it. Now let's take a look at some of these static software metrics. Fan in, fan out. This is a measure of the number of functions or methods that call some other function or method. Fan out is the number of functions that are called by a function X. High value for fan in means that X is tightly coupled to the rest of the design. Changes are going to have effects on it. Length of code is another static software metric that's fairly self-explanatory. The McCabe complexity. And again, if you have a higher McCabe complexity, changes to the system are going to cascade throughout the system. Number of different identifiers. The longer the identifiers, the more likely they are to be meaningful, and the more likely they are to be understandable within the program. Depth of conditional nesting. If it goes 7 or 8 deep in terms of conditional nesting, it may be time to refactor that code. And fog indexes measure the average length of words and sentences in a document. The higher the value of the fog index, the more difficult it is for it to understand. Now, my favorite is the fog index, and you can get an idea of what your fog index is by running this through Word and doing the spelling and grammar review and turning on the readability statistics. And last but not least is a final source for quality, and this is the Dilbert Principle. Now, this was a 1990s book by Scott Adams, and was actually the #1 New York Times bestseller. Now, according to Scott Adams, the meaning of ISO is some European dialect for "is that my beer?" 9,000 was the number they had to drink to come up with the idea. So this is really the only business book you'll ever need, and I'll read you a little bit out of the ISO9000 chapter. If your company is not involved in something called ISO 9000, you probably have no idea what it is. If your company is involved in ISO 9000, then you definitely have no idea what it is. Don't ask me what it is. I can't figure it out either, but I pieced together enough evidence to form a working theory. My theory: a group of bored Europeans had a few too many Heinekens and decided to play an elaborate prank on the big companies of the world. This prank came to be known as ISO 9000. So named because of the number of beers that were consumed that night. The phrase ISO is either an unintelligible phrase or possibly one of the 400 European slang words meaning, "is that my beer?" The inebriated Europeans correctly figured that any silly-ass management technique could become an international craze, if only they could keep a straight face when telling people about it. Their idea was that if companies documented every process and job description in the organization, this could solve a big problem that businesses have. That is, what to do with all their spare time. As predicted by the pranksters, customers began hearing the benefits of ISO 9000 and started demanding that their suppliers get with it. If you aren't ISO 9000 compliant, they reasoned, who knows what you're doing with all that spare time? Managers of big companies everywhere began documenting everything they did and labeling every tool they used. It was a frenzy of labeling and documenting. Slow-moving employees would go home at night and soak in the bathtub to remove the labels slapped on their bodies by overzealous coworkers. It was ugly. But the effort was not without reward for consultants. Consultants, who were having a tough time selling quality programs, quickly reinvented themselves as ISO 9000 experts. To the untrained eye, it might seem as though quality programs and ISO 9000 are not related. I was confused too until one consultant explained it to me this way. ISO 9000 is closely related to quality because everything you do is quality, and ISO 9000 documents everything you do. Therefore, give us money. I don't think any of us can argue with that.